Using the second derivative in part A, show that the curve y equals f of x has two local maximum points and one local minimum point. Okay, so the second derivative here, what we'd have to do is we would have to use the product rule in order to get the second derivative. So we're going to end up with the second derivative here. The second derivative being negative 2 sine 2x times negative 2 sine 2x times e to the power of cosine 2x minus 4 cos 2x times e to the power of cos 2x, like that. Okay, so at what happens at x is equal to 0? What if we set x equal to 0? Well, let's find that. At x is equal to 0, we're going to get negative 2 sine 0 times negative 2 sine 0 times e to the power of cos 0. Now this entire thing is going to go away because keep in mind sine 0 is 0, so we're going to have 0 times something else, well, times e, but doesn't matter what else it's 2, it's just going to end up being 0. And then minus 4 cosine of 0 times e to the power of cosine 0, which is just 0. So therefore, we're going to end up with this entire first thing being gone, and then negative 4 cos 0. Well, cos 0 is 1, so this is going to be negative 4, and then e to the power, so negative 4 times 1, and then e to the power of cos 0, that's just e to the power 1. So this is going to be negative 4e when we plug in 0. And because negative 4e is a value that's less than 0, because keep in mind e is just 2.7 something, right? E is kind of like pi in that it's just it's a never-ending, never-repeating decimal, right? It's an irrational decimal here. Negative 4 times a positive real number such as e is going to overall be less than 0. Then if we were to plug in pi, we would also get the same thing, right? Now, why is that? Because when we plug in pi, sine of 2 pi is the same as sine of 0. Cosine, it's going to end up giving us the same thing, right? We're still going to get negative 4e, which is still going to be less than 0. So the second derivative of when x is pi is still going to be negative 4e, so that's still less than 0, which makes it a maximum also. And then last but not least, what if we plugged in pi over 2? Well, that's going to be a bit different, so I'm actually going to do the work of plugging that in. What if we plug in pi over 2? If we plug in pi over 2, we're going to get negative sine 2 times x, so 2 times pi over 2, which is pi, and then that same thing again, minus 2 sine 2 times pi over 2, which is just pi, and then times e to the power of cos 2x, so e to the power of cos pi, minus 4 cosine pi, e to the power of cosine pi. Okay, so let's review what is sine pi and cosine pi. Well, sine pi is 0, so this all gets gone. However, cosine of pi is going to be different. Cosine of pi is negative 1. So in this case, we're going to get negative 4 times negative 1 times e to the power negative 1, which is going to be 4e to the power negative 1, which is going to be 4 over e. So therefore 4 over e, which is a greater number than 0, because remember e is just a positive integer, or not integer, e is just a positive real number, specifically set 1 in fact. And so therefore this is a minimum. So this shows what they wanted us to show, which is that there are 2 local maximum points and 1 local minimum point.